Okay, now here's another case. I call this case 2.5. Now, case 2.5 is that sigma 1, and sigma 2 is still unknown. Okay. However, right? However, what if we have some additional information that we can make an assumption such that sigma 1 equals sigma 2? Okay. So we call this pooled variance. Right. So the variance is pooled. Okay. So that means the variance of the two population is the same. Okay. So imagine we still are what we're interested in is is comparing the income between New York and LA. Okay. But for some reason, right, for some, we have information says that, well, we believe that the variance of the income in these two cities is the same. So if that is an assumption that we're allowed to make. Okay. All right. So this is an assumption. Okay. If we can make this assumption, then we will use then a different formula. Okay. So we still need to establish normality. That doesn't change. Our sigma bar is here. We still center at 0. Our standard error formula changes. Okay. So here's our new standard error formula. All right. It is S2P. Now, what is this S2P? So you do that on the side here. S2P equals this. Again, it's a long formula. I'm not going to say anything. I'm just going to write it down. Okay, all right. Now that is a very long formula, all right. And you might be thinking, well, what's the that looks a lot complicated than the previous standard error. Okay, but the benefit of making this assumption, or if we could, right, is that the degree of freedom simplifies dramatically. Okay, now the degree of formula is simply n1 plus n2 minus 2. Okay, much easier than before. And I would argue, right, that this formula is easier than the degree of freedom formula in the previous case. Okay, that's the hard part. Test statistic remains the same. Test statistic is theta bar minus theta naught. Okay, confidence interval. No difference here. Okay, where the margin of error equals, okay, where because we don't know sigma, right, we still have to use the t distribution. All right, let's do an example. Here are a sample of hourly wages of two different cities, and suppose we have information to believe that the variance in the two cities are the same. Okay, so let's formulate and conduct a hypothesis test. If you'd like to support a claim, the city B has a higher average wage than city A. Okay, for the sake of our notation, I'm going to go ahead and label city A as 1, population 1, city B as population 2. Okay, so take a second, think about what you believe the hypothesis test, right, should be. Okay, and go ahead and give it a try. Pause if you like. Okay, so that is what the hypothesis test should be. Again, the key word is read the question carefully, right? What is the goal here? Hypothesis test is the tool, right? So what would you like the tool to do? And we like the tool to support that B has a higher average than city A, right? What this is saying is mu 1, right, is less than mu 2, right? Now, so if you write this down, so what then, if that's the case, what is mu 1 minus mu 2? That is going to be less than 0. So this is the claim that we like to support. Therefore, it must be in the alternative. Okay. All right. Next. So let's go ahead and so we have our sample statistics here. So we can go ahead and calculate our point estimate, which is -1. And let's go ahead and calculate our standard error here. Okay, standard error, S2P. Okay, what's this S2 or S square P or SP square? Okay, I'm going to copy down the formula here again. So go ahead and pause the video, give it a try. Okay, plug it all in, do it carefully, and this is what you should get. Right? Now we can finish calculating. We can finish calculating the standard error. Right? Square root. Okay, put all that in. That's what you should get. Now we have the standard error. Let's go ahead and calculate the test statistic. Alright. To proceed, we need our degree of freedom. Let's go ahead and do. Now this becomes very simple. All right. Okay. Let's go ahead and do a p-value test, shall we? No. We have normality. Oh, actually, sorry. Give it a second. We don't, right? Because our sample is less than, both are less than 20. Okay. So we do need to assume. So we need to assume, right, that both population are normal. Okay, we need to make this assumption. Oh, sorry, let me write that down here. All right, we need to make that assumption first. Okay, once we make that assumption, then we could go ahead and draw our normal distribution here. Okay, because our sample size is not big enough, so we need to make this assumption. Okay, let me remind you, this is a strong assumption, right? Because we have no way of really knowing that the population is indeed normal. Okay, and here our test statistic, negative 1.24. Okay, this is a one-tailed test, so we just need that area for our p-value. Okay, so go ahead and just put it in your app. Okay, and what you'll see is you get this. Okay, all right. Now to do the test, oh, we need an alpha. Okay, let's pick an alpha. Let's let alpha equals 0.15. Let's say. Okay, now here's the thing, right? This is awfully close to, awfully close to 1.5, right? But because this, we still reject, right? So we reject the null. So if we reject the null, then we can support the claim. Now, what if, suppose I let alpha equals 0.10? Then we accept the null. Right? Then therefore we cannot support the claim. So remember, that's our goal. Now, which one is right? Well, the short answer is no, there is no right alpha, right? Because remember, alpha is the amount of risk that the researcher is willing to accept for making a type 1 error. So you, right, are, I'm going to choose alpha for you, but when you do research on your own, when you do your own studies, right, you can choose alpha. And so when you get a p-value there, right, depending on the alpha that you choose, right, you can reject the null and have the study to support your claim, or you accept the null and you cannot support the claim. Now, whether or not, which one you're allowed to do, well, that just depends on how carefully, right, people are actually looking at your study. Okay. All right. So that is all for chapter 10. We're going to skip the population proportion, or hypothesis test on the population proportion. Overall, it's the same. We just need more formulas. Okay, but I think this is plenty of useful things here. And if this is enough, you'll learn enough here so that if you do want to perform tests on population proportion, you can now you know how to look that up in the textbook.